laughing about something. All of you all can do that too, by the way. Presidential Pete is on the home stretch of his campaign and wants to know if the polls predict that he'll win the election. A recent poll of 1,020 randomly selected voters found 484 responding in favor of Pete. Construct a 95% confidence interval for the true proportion of voters who will vote for Presidential Pete. We just got to do the 4 steps. Step 1, name the test. This time it's not a test, it's an interval. Name the interval. What's the name? Yes, Jennifer. No, sorry. I'm doing number 2, which is, yes, it's the exact same prompt as this one, except this is down here. The prompt is the same. We did this one, would you agree, where I put my black arrow? Now I'm doing this one. Good point. Okay, name the interval. This is a 1 sample Z proportion, thank you Dex, interval. And all you have to do, folks, is just like we've been doing for the past 5-6 weeks. 1 sample, because we're only looking at 1 group. It's Z proportion because we have a categorical variable, right? It's categorical because either you're voting for Pete or you're not. Success or failure. Either you're in the camp of yes, I'm voting, or the camp of no, I'm not voting. We also need to just define the P equals the true proportion of people voting for Pete. Number 2 is the conditions. There are 3 conditions. We always have random. Does it tell us in the problem it's a random? Yes, it does. Random is given. Number 2, independent. One person's opinions don't affect the other person's. The 3rd condition, NP greater than 10, N times 1 minus P greater than 10. The conditions are the same. We've always had them. NP greater than or equal to 10. N is 1,020. P is, you can write down here, P hat is equal to what? Well, 484 divided by 1020. We got to do this on the calculator. Let's see what we get. What do we get, by the way? What do we get, folks?
480.
0.4745, I think. Wait,
That's
no,
fine.
no, I was wrong. No, that's not it. That's not it. Oh, no, it is. 4745.
Okay, this goes here. Of course, you could also just put the 484 over 1020 here. That's fine too. This will be equal to 484. Then you do N times 1 minus P. See if that is greater than or equal to 10. Well, 1020 times 1 minus 0.4745, and that's equal to 536. I won't explain how to do the calculations. We spent so much time on this last year. And the last condition is the population is 10 times as big as the sample. So there must be, what, 10,200 people or more. Conditions are done. Now you go to math. Except in the math, we're not going to do the whole hypothesis testing. The math is the confidence interval part. So let's do that. So the math is confidence interval equals what? It equals p hat. That's the statistic plus or minus the margin for error. And the margin for error is z star times square root of p q over n. Let's plug in what we know. CI equals p hat was 484 divided by 1020, whatever percentage that is, plus or minus z star. Well, go back to your chart. We want a 95% confidence interval, and we want proportions, so we want 1.96. Again, if I'm saying, like, I don't think this is conceptually difficult. It's just a little bit tedious. Okay? PQ over N. So what is P, what is Q, and what is N? Well, P is, well, 484 over 1020, whatever percentage that is. N is, Q, remember, is just 1 minus P, which is, again, some percentage. I'm not going to put the number in because I don't have my calculator on me. Oh, you have it?
It is right.
Okay. And then we just, Frida, 536 over 1020. And then the way we got that is we just did 1020 minus 484. If it's better, you can calculate out the P and then just write that as 1 minus P. You have it? Norma, can I use your calculator?
I have it right here.
I think you're lazy to go back. So now we just come to the calculator and let the calculator do the work. Calculate, menu, statistics, that's number 6. Confidence intervals, that's number 6 again. And then you want a one proportion, z interval. Click enter. How many successes did we have? How many people voted for Pete? 484. What is our N? How many total people? 1020. 95% interval. Click OK. There it is. There's the answer. Lower 0.4438. 39 if you want. And the upper 0.5052. On the 8384. Stat. Tests. Go down to one prop z int, which is letter A. Put in the x, which is the number of successes, which was 484. The n is 1020. Bless you, confidence level is 0.95.
You put 100.
Huh? What'd I do?
You put 100 and so.
Oh, okay. What is it supposed to be? 1020? Yeah. Okay. There we are. And there you have it. There's the answer. That's all it is, folks. We're not asking you to do anything. We're just asking you to spend the time setting things up. That's it. Questions on this? And then there's one final. Yes, Shamara?
You said we were going to get a sheet that's all this.
Yeah, I didn't have a time to print out, but tomorrow or Friday for sure. Absolutely sure. Okay, and then we And then we gotta write the sentence, that's it. What's the sentence, Alex? You got it. You're gonna do this, Alex.
Oh, we are.
Okay, hold on. Let me write it here. We are, okay, keep going, Alex.
Yeah, we are 95%
Excellent.
confident
Yep.
that
What are we measuring, Alex?
that the true proportion of people voting for Pete is between 0.4438 and 0.5050.
Absolutely. The only thing I would say this is, and you're totally welcome to do it the way Alex did. The only thing I would have done differently is 44.39%, or is between. So I would have just made these a percentage. That's the only thing I would have done. Because this is a proportion, so it's really the percentage of people voting for Pete. One more time, Kendra? Because yesterday it was not a proportion, right? It was just like the speed of light, which was a quantitative variable. So that's not a percentage, right? But this is a categorical variable, so it's the percent or the proportion. You see the difference there, Kendra? Yes? Okay. That's it. What's the next question? Do we think Pete's gonna win? Do we think he's gonna win? So to win an election, assume there are two people, you have to get more than 50% of the vote. Do we think he's gonna win?
No.
Alex, why do you say no?
Because his max is barely 51.
Yeah. His max is only a little bit more. And the min is a lot less. Norma, you had a question? No. Oh, yes. Thank you. Go ahead and draw the picture. Very good, Norma. I apologize. Thank you for reminding me. So you can draw it you can either draw it like on the negative, you just draw the negative side as well if you want. You don't have to draw on the negative side because clearly there's no way a percentage is going to be negative. Thank you, Norma. Very good. So yeah, he's probably not going to win. For the reason exactly what Alex said. We predict like he's going to be somewhere between here, and there's so much space down here below 50%, not too much space above 50%. Okay, what sample size would you need to have a margin of error of only 0.03? What sample size do we need to have a margin of error of only 0.03? So think back to yesterday. This is the margin of error right here. This is the part that's margin of error. So we want that to equal 0.03. So just set it equal to 0.03. Just make the margin for error equal to 0.03. And now solve. 0.03 Z star is still 1.96 because he's saying still with a 95% confidence interval. Our p-value was 0.5.